Thank you very much for your kind introduction. I'm Seizo Koshiba, and today I will talk about Tohoku Medical Megabank project, Cohort and Biobank. Tohoku Medical Megabank, called TMM, established on February 2012. We wish to deliver the most advanced medicine to the people who suffered from the earthquake and tsunami of March 2011. We think that the most advanced medicine in the personal medicine and healthcare, so population studies based on the cohort and biobanks are essential to promote the personal medicine and healthcare. There are two cohorts. One is community-based cohort. The other is Earth and 3-generation cohort. And in community-based cohort, we recruit more than 80,000 residents from coast area in Miyagi and Iwate prefectures. And the other cohort, birth and 3-generation cohort, we recruit more than 70,000 people, include offsprings, parental, and grandparental generation. So we started this cohort from 2013, and 2016 we have finished the recruit of 84,000 participants in our community-based cohort. And 2017 we have finished recruit of more than 73,000 for birth and 3-generation cohort. So we successfully recruited more than 150,000 participants in total in the two cohorts. And from 2017, we started follow-up survey, and now we are continuing the second repeat survey. So our target disease is common disease. So theoretically, prospective cohort treats all the diseases that arise in the participant. But our major focus is a common disease that involve in interplay between genetic and environmental events. And we have been informing participants 5 major diseases that we will especially work on: cancer, cardiovascular disease, strokes, diabetes, and mental disease. We also inform participants that we will work on diseases that are related to the earthquake damage. During our cohort surveys, we collected many kinds of items. So mainly lifestyle information by questionnaires. Major items is standard items such as exercise, alcohol consumption, smoking, diet, and others. And in addition, disaster-related items such as depression, stress, and others. And we also have information such as detailed service at our admission centers, mainly physiological examination, such as audiometry, body consumption, and others, and especially part of participant MRI imaging and others. In addition, we also analyzed blood and urine, and now we are continuing a follow-up survey, and we also collecting such information. For a part of participants, we also collected magnetic resonance imaging in combination with cognitive and psychological data collection. From 2014, we started, and we have already passed a trial, and we collected more than MRI image and psychological data from over to 12,000 participants. And from 2019, we started follow-up survey, and now continue. For all participants, we are continuing follow-up survey, and during this follow-up survey, we collected many kinds of items from participants. First is mail and web-based questionnaires for getting health outcomes or information from the resident registry. And second is medical information, national health insurance subscribers, information of public health examinations, and electronic medical information collected from regional medical welfare network. The third is public data and registration of disease and outcomes, and infant health checkup information, regional cancer registration data, and demographic statistics. And the fourth is on-site survey. We collect every 5 years from participants, and the physiological test and blood sampling, and add-on research data and collaboration with industries, and live log using mobile devices. We just said all collected data are stored, of data and sample are stored to Biobank. And one of the characteristics of when Biobank is an integrated biobank. So integrated biobank, Tomo set up an analytical center that executes standard analysis of samples to avoid rapid depletion of samples. Tomo distribute analysis information first and the biosamples. For this purpose, we analyze blood and urine for metabolic and protein. And by using DNA, we analyze genome and transcriptome. And we also collected the questionnaires for lifestyle information. And for part of participant, we also collected MRI and other physiological data. All these data and analyzed data are integrated to Biobank and distributed to other options. So all these data are stored to Biobank and managed by database Tohoku Medical Megabank, TMM, which helps users to industries to identify samples and information of interest. So all these data, not only collected data, but also analysis data. All these data stored to Tohoku Medical Megabank database, TMM. And these data transferred to scientists and academic and in academia and industry through TMM. So for this purpose, we also make a special data distribution system, remote security area. Traditionally, it stored data for each site and sharing, but now in this TMM system, all these data are stored to Tomo supercomputer system, and all researchers access to this data by using remote security system. So we have already opened more than 30 locations, remote security area, and researchers in Japan access from these remote security area to Tomo supercomputer and analyze the data in this system. So next session, I'll talk about genome and omics analysis in the TMM cohort project. So all these data are stored in Biobank system, but we also make a special database, Japanese multi-omics reference file. This is open database for TMM, genome and omics information. So now we are conducting many kinds of genome and omics research, such as genome, metabolome, transcriptome, proteome, epigenome, and metagenomes, and others. And for example, for genome, we have already collected whole genome sequence for approximately 50,000 cohort participants. And for omics research, we have also collected more than +1 metabolic data from approximately 50,000 cohort participants. And in addition, we have also collected other omics data, such as epigenome data. For epigenome data, whole genome DNA methylation database from 100 Japanese cells. And in addition, we have also collected transcriptome and metagenome data. So, for example, for metabolome research, our main purpose is identification of biomarkers for healthcare and investigation of association of omics with genome and other environmental factors, and analysis of metabolite of diet and medicine. So, for this purpose, we use two kinds of methods. One is mass spectrometry, and the other is nuclear magnetic resonance. By using this system, we have already collected more than 50,000 cohort participant metabolic data. So, I think a main role of molecular phenotyping in cohort study is two roles. One is a classification of cohort participants by molecular phenotypes, especially in the baseline surveys. And we classified participants by using based on molecular phenotypes. The other is surveys of phenotypes change over time, and to elicit the effect of lifestyle, aging, or other factors to the change of phenotypes by molecular phenotyping. And by using these data, we finally, our main aims is to develop biomarker for disease and healthcare, and finally make a method to estimate risk for disease onset based on genome and omics data. So by using these genome omics analysis, we collected many kinds of data. So for providing statistical information to free, we made a special database, Japanese Multi-Omics Reference Panel, JMO. This database is normal integrated database for the statistical information of genome and omics collected from participants in TMM cohort project. We opened first version from at 2015, and recently we released new user interface of JMO for the convenience of users with a wide variety of interest. This is new interface, and this is a list of genome and omics information available. So this is a detailed list of genome and omics information available on JMO. And for genome, there are two information. One is a Japanese reference genome sequence, which was made by de novo assembly of Japanese genome. The other is SNV indel and or structure variant information based on whole genome sequence data. For example, SNV or indel is obtained from a short read whole genome sequence of 38,000 Japanese participants. On the other hand, for structure variant information is based on a long read whole genome sequence of more than 300 Japanese participants. And in addition, we also provide many kinds of omics data, such as metabolome, transcriptome, and of course, metabol data. For metabolome, mainly plasma metabol data. One is 53,000 Japanese participants by NMR methodology. The other is more than 10,000 Japanese participants by mass spectrometry use this biocrates system. And other information is such as pharmacogenetics, metagenomes, and also you can access the result of GWAS studies in TMM project. So main search you can access mainly by search window. If you want to know single nucleotide the polymorphism, and for example, you can search specific SNP by using RSID. So you can get many kinds of information, and mainly allele and genotype frequency in the Japanese and other aspects. And many kinds of other information are included, such as GWAS hit information. And if you want to get information for a specific gene, you can also search by gene names. And for each gene, you can obtain many kinds of information, such as SNV in their informations. And in addition, methylome, transcriptome, and for transcriptome by cells, and in addition, isosec transcript information that is also available. In the case of metabolite information, you can search metabolite names. By using this system, you can also get many lists related to target metabolite, such as gene related to the metabolome list in TMM, and GWAS related to the metabolite. So for metabolome, you can access each metabolite by clicking specific metabolite link. So in the case of each metabolite, you can obtain many kinds of information, such as basic information, linked to other database and structure in formula, and distribution in plasma in TMM cohort participant, and age dependency of metabolite, and change during pregnancy, and difference between baseline and repeat survey, mainly 4 or 5 years apart, and correlation table of specific of target metabolite to other metabolite, and effect of genetic variance MGWAS results. For difference between baseline and repeat survey, and you can also obtain other information, not only sex dependency, but also age dependency and genotype dependency. And for correlation table, you can also analyze information based on network viewer. In addition, you can download the correlation table. So in the case of genetic variation effect, and you can also access MGWAS result in TMM. So you can obtain such information for each metabolite and Manhattan plot and associated SNPs. So for each SNPs, you can also access to these information. So there are many kinds of other information on genome. For example, metagenome. For metagenome is information. You can obtain information of microbial abundance in plaque and fiber based on amplicon sequence. And you can search microbe based on taxonomy and relative abundance depend on periodical disease survey, sex and age, smoking, and pulmonary functions for each plaque and survey. So this is summary Tohoku Medical Megabank project conduct two prospective cohort studies, and our major focus is common disease. And this project many kinds of information and samples are collected from participants. Okay, and other information also obtained, and we also conduct genomics analysis of samples and start to database, and we also open database GMOP is provide release. So this is our colleagues. Thank you very much.